We'll start with entity. What is already we have discussed brief. What is entity? So as we can see, this entity is an object. So as we have discussed, like in any business, whatever objects are there or whatever things are there, basically those things are those objects which initiates the process. We refer them as entity. So when we go to any business for data modeling, whether it is for entire organization or it is for maybe part of the organization. So there might be so many entities. The only thing we have to find out what are the entities basically they want to capture, means what are the entities they want to record or they want to use in their system. It means in their IT system or in their manual system, what are the entities they are dealing with. So those entities we need to identify. So when I say we need to identify means basically it is the role of a business analyst to discuss with them and find out what entities are there. But if you are working as a data modeler come business analyst, then it is your responsibility to find out the entities. Entities can be basically of two types. Some of the entities are physical entity and some of the entities are logical, or you can say virtual or non-tangible. So tangible entities means the entities which are physical, which you can see, you can touch. So those entities we refer as a tangible entity. But the most of the entities or many entities in the organization will be non-tangible. They will be abstract. It is like a virtual entity. So for example, when we talk about person, so person is a tangible entity because you can see the person, you can touch the person. So whatever things you are able to see, you are able to touch, we refer them as a tangible. So person is one entity. But based on one physical entity or tangible entity, there might be so many virtual or logical entity which will be derived from this person. For example, when you take example of any bank, so they refer it as a customer. So customer is a virtual entity. It is not tangible. Person is a tangible, but from person they derive. See, this is customer. So if you say what is the shape of a customer, what is the color of a customer, nothing. Person has a color, person has a shape, person has an appearance, but customer is derived from the person. So like that, you will find, okay, there is a customer is there. Then they say there is a staff is there. It may be possible they say staff, we have a different type of staffs, manager, all those. So then they might say, okay, apart from customer and staff, we have a vendors, we have a, like
रहीम भाई सॉरी टू इंटरप्ट, वो परवेज वेट कर रहे हैं, उनको भी एडमिट कर दीजिए.
अच्छा. Yeah, is that it? So these kind of entities, which we refer as a tangible and abstract entity. So based on one tangible entity or one physical entity, there might be many virtual or logical entities. In the business, you will find that most of the time, when we define our entities, generally we don't take physical entities. It is like most of the time we use the logical or virtual entities or non-tangible, which are derived from the physical. For example, when I'm saying in the bank, a person is a very physical and very wide entity. Means a person can be derived in so many different sub-entities or virtual entities. Like I said, customer is there, staff is there, maybe like a vendor is there. But sometimes they refer it as a party. So many different names are defined, or you can say so many different virtual entities are defined. And these virtual entities basically are defined based on their functionality or based on their usage in the business. Like customer is there, which is a virtual entity. And we know that a customer is nothing but a person. But sometimes you'll find a customer is basically a company or a firm, means it is a non-person. So again, if you say what is a company and what is a firm, you will find that, okay, these are basically, again, a derived entity. It is not like a physical entity. A company may be a group of persons which is defined as a company, and also they have added some added feature from the government that, okay, these are the rules When a group of persons are registered with certain name, they have to follow certain rules. So that entity they refer as a company. So ultimately, you'll find that at the very back end, you have a one physical entity or maybe group of physical entity which are derived as a different logical or non-tangible entities. So question here comes, when we are transforming this entity into our database objects like a table, should we take the tangible entity, means physical entity, as a table, or should we take those logical or virtual entities? So here we sometimes, if you see the database, you'll find that in some database they will define physical entity, like they say person or they say party, and then they say okay, person can be of different types. So they will have another table where they say person type. So there you will find they will define employee is one person type, firm is another person type, customer is third person type. So that is one way. Other way is, which is more common, directly we take the virtual entities as a table within the database or file within the file system. So when we are developing a system which has to be very flexible, it should be able to grow for any type of requirement in future. Then basically we take these physical entities and then we define the different type of what is physical entities. So this kind of approach basically takes you to the very means high level of database design, or you can say very flexible approach of database design. And designing such system takes a lot of effort because you will find so many entities will be there, or you have to make a relation among those virtual entities which are basically part of these physical entities. So when we are talking about a very flexible system, then we take this approach where we define the physical entities and then we define the other entity which will define what is the type of these physical entities, how they are related. So it is like a through, instead of table, you are basically making the relation based on the instances of the table. It is like you have a one table person, and inside that table you have so many instances, it means so many records which are basically virtual entity. And then how these virtual entities are related, you are trying to relate them again with the help of some entities and their instances. So it is very complex approach. So it makes a system very flexible, means it can keep on growing like anything. But the only problem is developing the database takes a lot of time. Developing the application based on such database requires a lot of time and investment, means it is naturally when time is more, investment has to be more. So this approach only works when we are working on the product kind of development. I mean, it is like a company which is involved in product development, and that product can be used by any kind of client, means whether it's a small client, mid-size, large. So if you see this, when it comes to mostly US companies, they develop the products. So when they develop the products, and if the product comes with its own database system, whether it is file-based or data-based, then they will apply that kind of approach because they don't know who is going to be the client. And it is not like they customize this product for each and every client. It is like generic product is there, you purchase it, buy it, and then use it. So in such cases, you need a flexible database which should be self-growing or self-shrinking as per the requirement of the client. But when we go to this specific business, a small, mid-size, or large, if there is a specific requirement and they have very limited time period, it is not like they can give you a very big amount of time, means year, 2 year, or 5 years. So when they have very limited time period and limited budget, then our approach is to basically design the data system or database objects based on these abstract entities which are derived from the physical. So instead of taking person as a table, what we do is, okay, let us find out what are the logical entities you are using. So you are using customer, you are using the employee, you are using vendors. So we start creating the table based on these virtual entities. So instead of one person table, now we create three table, one employee table, one customer table, one vendor table, or maybe more. So it depends how many logical entities they are dealing with. So this is one important thing. Once you understand physical entity and the derived entity from those physical. So simple language, we refer them as a tangible and non-tangible, or physical and virtual. So this is important. And since now we started using these virtual entities or logical entities in such way that they have become a routine of means routine objects of our daily life uses. So it has become very tough for us to
Naim
basically
bhai,
yeah,
which one is better? Tangible, deciding, and
non-tangible.
intangible?
No,
So,
non-tangible. When you are developing a system for a specific client, for a specific requirement, where you have a very limited time period and limited budget, then you have to go for this non-tangible approach. But suppose if you are developing something, product kind of things, and for that product, you require some database system. And such products are basically very generic in the usage. It is not for a specific client. It is for any group of client can use. It is like I'm developing a product, I'm giving it to the market like ERP system. And this ERP system can be used by any company or any client who is buying it. And generally, this customization will not be like for each and every client. So it is like, okay, you purchase my product and use it. Like you take example of operating system, that is a product. So Microsoft or other companies are selling the operating system. But if you see this, every operating system maintains a database. Only thing is they maintain the file-based database. So for them, they don't know who is going to use it, what features they are of this product they are going to use. So their database system is very flexible. So according to this usage of the product or client, they basically will use what are the database files or database things they will be using. Like you take example of ERP system. If you purchase Oracle Financial, so you'll find 3,000 tables are there. But as per the maybe that company requirement, it might be possible it is a small company. So it might be possible that they are using out of 100 features which are given, they are just using only 20 feature of the product. So that means whatever database is at the backend, many of the tables will not be used. They will be there, structure will be there, everything is there, but data will not be there because those 80 features which they are not using are basically not part means utilized by the client. So it means the tables which are attached with those 80 features, they will be blank. They will have no data. But table structure is there. So developing such type of products requires a lot of R&D. It requires a lot of time. It requires a lot of investment. But advantage is once these kind of things are developed and they become popular in the market, it means they click in the market. Then company just makes a revenue. It is like just keep on selling the product and generate the revenue. So one-time investment and then keep on selling it and getting the revenue. But if you see, when we are developing a user-specific product, means a bank says that, okay, I need my transaction system computerized. So it is like ICICI Bank is asking. So one of the solution provider has to go there, study their requirement, design the database as per their specific requirement, develop the application and deploy. So that product is only for ICICI. But suppose tomorrow, maybe if SDFC Bank says that I also need a transaction, same product, exactly same way you cannot deploy. So it will require a lot of changes because business rules of this second bank might be changing. The scope of the second bank might be changing. So according to now, this second client, even though they are bank, again, you have to go and analyze their requirement, gather the information, design the database. So it may be possible that whatever database you designed for one bank, you might be using it 70, 80% or 60% you will be using as it is. But those 30, 40% you have to customize. So it is like for same domain, we are developing the product, but again, we have to start process again and again. So it is like maybe first product, we invested 100%, means our effort is 100%. When we go to the same type of domain for another client, instead of 100%, it might become 60%. When we go to third, it might be 70, 75%. But we have to initiate the process again from scratch. And thing is, some of the things which we have done earlier, we can reuse. So that is our target. So at this stage, we are not basically targeting those clients who are developing the product kind of things and they need a very flexible database system. So here our target is very different. We are targeting those clients for whom we have to develop the database system. Based on that, applications will be developed. So in this second approach, mostly we define entities which are abstract entities, basically derived from the physical entities. So it is like specific entities we take we define them, we define their relation, and then complete our data model and give it to the development team. So the only problem is means when we are working, and then it becomes very tough for us to differentiate whether it is a physical entity or it is a logical, because we started using this logical entity in such way that for so many years that they have become part of our routine daily activity. So we think that they are physical. Like you see this customer. If many people you ask customer is a physical or logical, they will say physical, because we are using the customer like as a part of our daily routine activity. But actually customer is not a physical, person is a physical with some of the features. Means if you take some of the customer feature, he will become customer. So customer is a person who basically buys the items or buys the product or buys the services. So either it is buying the product or buying the services. So he is a customer. Then if you say who is the account holder, so account holder is a person who basically opens an account in a bank where he can deposit the money or he can withdraw money or he can use banking services. So you will find that same person with one set of features becomes one logical entity, with other set of features becomes another logical entity. So basically, in a very simple, you can say that based on the functionality, we have defined a physical entity with so many logical entities. So only difference between, or you can say among one logical entity to another logical entity, which is derived from the same physical entity, is the functionality. So what is the basically functionality they are involved with? So maybe a very small functionality change might be there, only one or two feature might be there, but that is enough to make as two different entities. So this entity understanding is very important. And if you go back to the noun approach, what we have discussed last time, so in a noun, you basically what you define is you have a proper noun, you have a common noun, you have an abstract noun. So that abstract is nothing but virtual. So here we are referring them as a virtual entity. And how to define the entity? Sometimes, like in interview, when I ask what is the entity, they start giving the example of attributes. So entity is basically defined by its attributes. So it is not like attribute becomes entity. So every entity will have at least one attribute. It means one feature. Generally, it will be many. Only one feature or one attribute will not define the entity. There will be many features or many attributes. So every entity is defined by its properties or attributes. Some of the properties might define the identification, like you take person. So when you say person, name is attribute which defines the identity of the person. Some of the attributes will be which defines the behavior. Like when you talk about, suppose you take customer and you say customer designation. So designation is nothing but it defines what is the behavior of this person. So when you say manager, so he has to behave in one way. When you say he's a clerk, he has to behave in another way. When you say he's a cashier, he has to behave is a third way. So some of the attributes will define what is the behavior of this entity. And then some of the attributes, like I told about physical. So when there is a physical entity, there will be some attributes which will define the appearance. It's like when you talk about color. So you will find that person will have a color, but when you go to customer, there will be no color. So in customer table, you will not find any color. But when you go back to the person table, there will be color. But now here understanding thing is, when we are not defining the person entity in our database, it means there is no table for person. That means you are working only with the virtual entities. Now, if suppose I'm defining a customer as a table and this business says that I want to know what is the color of the customer, that means he wants to incorporate physical entity attribute within the logical. So it means within the customer, he wants to define the appearance also, like what is the color of the person. Why this is happening is because we are not having a physical table person. So basically a proper approach should be, we should have a person table. Whatever attributes or whatever features are common among all these virtual entities, they should be defined in the base table person. And the rest of the virtual table, which are basically differentiating from one virtual entity to another, they should have only those features or those attributes. So it should be like a person is inherited by customer, person is inherited by maybe like staff, person is inherited by vendor. But since we are not going in object-oriented approach, so what we do is we remove the person table, means person entity. Now, whatever those attributes are there for person, that is for physical, those attributes we carry in all these virtual entities. It means in the customer, you will keep what is the color. In staff also, you will keep what is the color. In vendor also, you will keep what is the color if he is derived from the person. So this is the important part, because what is happening is we are not keeping the physical entity. We have removed completely. So whatever attributes are basically part of the physical entity, which is common for all the logical, we are copying into all this logical entity. And that is why if you see, when you look at some of the tables, you'll find that, okay, there are means 10, 15 columns are there, which are common in 5 or 6 different entities. So if you check closely, you watch closely, you'll find that these entities basically are derived from the one single physical entity. And since physical entity is not there, that is why the attributes which are common, we are copying in all these entities, means all these virtual entities. So as soon as you remove this base entity or physical entity, you'll find that there is a duplicate data elements. That is why we say that there is no database which is fully normalized, because practically it is not possible. We have to denormalize. Either it is you are doing it knowingly, it means you know that why these attributes are repeating. But most of the people, they do it without knowing. And if you ask why you are repeating this, for example, you take, I have an address. Now address column, 5 column for address I'm keeping in customer, 5 column for address I'm keeping in staff, 5 column for customer I'm keeping in vendor also. So if you ask someone why you are repeating these columns in 3 tables, why don't you keep in 1 table? So they say, no, no, no. Means they will give you answer, no, no, if you don't keep it, then where you keep? So we can say like, okay, you can keep in one separate table address and then use that table as a foreign key for this table. So they will say, no, but number of tables will increase. So the time you say that number of table will increase, and to avoid this number of tables increase, I'm keeping it in the same. It means you are talking about denormalization. Because denormalization first rule is reduce the number of tables. How you can reduce? You merge them. So that is the first rule of denormalization. Second rule is reduce the number of columns. You merge them into single column. That means you don't keep first names, middle name, last name. Don't keep 3 columns. Merge it as a single name, customer name. So when you remove these 3 names and you keep only 1 name, it means again you are going for denormalization. So these are the 2 basic rule of denormalization. Reduce the number of tables. Second, reduce the number of columns. So that means you are avoiding a multiple and making it 1. So it is by default, means unconsciously you are doing the denormalization. Only thing is you are not knowing the rule. That's all. And when somebody says why you are doing this, then you have no answer. Basically, you try to explain with whatever example you get. So you start giving example rather than giving the definition why this has been done. So something which we are doing, if we know why we are doing this way, that makes you intelligent that, okay, I'm doing normalization proper or I'm doing denormalization. If I'm doing normalization proper, naturally number of tables are going to increase, or number of columns will increase, and it will require more effort for designing as well as for development, testing, and deployment. If I'm doing denormalization, these things will be reduced. But there is a drawback also. Your database at certain point is going to be compromising. Means beyond this, you cannot extend until you make the structural changes in the database. So if you make the structural changes in the database, then the rest of the activities are going to be affected. So it means you have to change the applications or program, you have to go for retesting, you have to go for redeployment. So both have advantage and disadvantage. So knowing this, whether you are doing more normalization or you are doing more denormalization, either you do it by knowledge or without knowledge. So if you do by knowledge, you know where your application will have a restriction. Beyond that, it cannot go. Or if you are doing without knowledge, then you always, like, you might have heard about people say, no, my database is very flexible. But after a certain point, you find, no, it is not flexible, it is not extending, now I have to design. Then you ask that fellow, but you said it is very flexible. So he has no answer, because he did this denormalization without knowing that he is doing the denormalization. So whether you are doing mistake with knowledge or you are doing mistake without knowledge, if you are doing mistake without knowledge, then it is a mistake. But if you are doing a mistake with knowledge that I'm doing the mistake, that is a denormalization in database. So these attributes, basically entities are defined by different attributes. So identification plus behavior, you'll find that these two set of attributes will be there with nearly all the entities. Third one, which is appearance, it is only when the physical features you require. Means it is like you are working with the tangible entity or non-tangible entity, but you need some physical appearance. So in that case, so you can say appearance-based attributes are optional. It is not compulsory, but first two are compulsory. So these things, when we know, suppose if you are going for a customer table and you take a customer table from any of your project and see what columns are there, and then start looking at those columns, and then very easily your mind will start working. Okay, customer ID is there, so it is identification. Customer name is there, identification. Customer address is there. That is for what? Again, that is for identification, because it is not for a behavior or appearance. But when you say customer designation, customer role, all these are basically defining the behavior. Then you find there is a customer color, customer height, customer width. This is for appearance. So then it will be easy for you to group them. Suppose if you want to break your customer table into multiple table, because number of columns are increasing very high, then you can easily group them. Okay, let me take this set of attributes as one table, this set of attributes in other table, and this set of attributes in third table. Or whatever attributes are compulsory, I should keep in one table. Whatever attributes are optional, let me keep in other table, so that you can split the table vertically. So it is like having the knowledge, and then you are working on the model. So it makes, as I said, design by mistake or design with knowledge. So if it is by mistake, you are going to struggle at one point of time. So this is the entity and entities with attributes. So every entity will be defined by the attributes. Now, sometimes people get confused. How I know whether it is an entity or attribute? So there is one simple way is there. Means it is like if you ask one question, what is? If you ask what is with any entity, you will not get a value. You will get definition kind of things. But when you put this question, what is with the attribute, you will get the value. Means, for example, if somebody says, what is your name? Immediately you'll say, my name is Ashok, my name is Rashid. So immediately you get the value. But if somebody asks, what is employee? Then you don't have a value. You start giving some definition. Okay, employee is a thing which basically is working for an organization. So you start giving definition. So this is the simplest way to know whether this is an entity or this is an attribute. Just put a question, what is? And if you are getting a value, instant value means a direct value, it is an attribute. So whenever there is a doubt, whether I should take it as an entity or I should take it as an attribute, just check this, what is. That is very important. Means what is color? Black. What is color? White. So immediate you get the value. What is ID? 1001. So it is an attribute. So in grammar terms, entities are defined as a noun and attributes are basically your adjective. So if your entity is a noun based, you have adjectives. If your entity is a verb based, you have adverbs. So it is very simple. Noun, adjective, verb, adverb. So that is the grammar. So if somebody if he's good in grammar, then for him it becomes very easy to identify the entity and attributes. Then yesterday we have discussed about these entities. So master entity, transaction entity, and a reference master entity. So yesterday we have seen this, means last time. Master entities are those entities which initiates the process directly. It means their association with the process is direct. Reference master entities are those entities which basically are related to other master entities. It means reference master entities are not directly linked with the process. So they are not responsible to initiate the process directly. So you can refer them as a passive entity also. So it is like an active entity, active master entity, and passive master entity. So both are master because both are noun based. The only thing is one set of entity is directly linked with the process. Other set of entities are linked with the master entities rather than process directly. And transaction entities are simple. They are activity based. So in a simple way, noun or verb. Master entities are noun, transaction entities are verb. So if you take in the grammar, it becomes very easy. And if we have studied English, we right from the childhood we are studying the grammar. So whatever level we know, we don't need to be a very expert in the grammar. Just very basic what we study in fifth or sixth standard. That grammar is good enough. Means what is a noun, what is a adjective, what is a verb, what is a adverb. So these four things are, we don't require any other things. If you know these four things, noun, adjective, verb, adverb, that's all. Nothing else you require. Then it comes a relation type. So when we are dealing with the ER model, we basically try to identify what is the type of relation between two entities. So there will be so many entities. Means when you are going to design a database, you will find hundreds of entities will be there. But whenever you are trying to relate the entities, don't take beyond two. Means always pick up two entities. If you try to keep 10, 20 entities in front of you and then you try to relate them at once, you will do mistake. So the best practice is out of those 50 or 100 entities or whatever, you pick up first two entities. How you pick up? Take those two entities which have direct association. Means in between those two entities, no third entity is there. So this is a challenging job because when you don't have a domain knowledge, then it becomes very tough. That is why they say that a person who is doing the modeling, he should have a basic domain idea. He should know. If he doesn't know domain, then 100% he requires assistance from the business analyst who is a domain expert. But if suppose for each and everything, if you start asking from a business analyst, again, it will be a problem. So it is not possible that a data modeler is completely unaware about the domain. He has to. If you don't know domain, suppose you know that, okay, next month I'm going to get a project for XYZ domain. I don't know anything about the domain. Then it is your responsibility to study something about the domain. So either you study online or buy a book or whatever, but you have to know the basics of the domain. Because this, when it comes to relationship, you cannot identify the relation between entities until you have an idea about the domain. When somebody says, I don't understand banking, then how you define customer and account relation? Means how you know that customer has a direct relation with account, or between customer and account there is some other entity or some other process. So it is a must. You have to have a domain knowledge, basic knowledge. So before project comes, you study and get ready with the basics. You don't need to be expert because a data modeler cannot be expert in all the domain. He's working like every year, he's changing his role. Role means project. And you can say good luck or bad luck. Every project is from a different domain. So it is good in the sense like you are getting so many domain knowledge. Bad in the sense that every time you have to struggle. You have to study before the project. But once you study two or three domain, means you have an idea about the two or three domain. That means 70 to 80% of the things you know by default for any domain. Even though that domain is completely new for you, still 70-80% things you'll find entities are common. 20% will be 25% entities which will be new in that domain. For that, you need to have understanding, but 70-80% by default, you know. That is why people, they ask a data modeler with experience. Generally, you will not find the data modeler like they say, okay, freshers as a data modeler. They don't. Always they look for data modeler with 3+ years experience in minimum, because by the time he has done 2 or 3 projects, small or mid-size, so he has an idea about the 60-70% of the entities he knows by default for any domain. So this whenever you are going to start a relation, just pick up 2 entities. And mostly when you pick up the 2 entities, make sure that you should start from the process. Never start from the subject. That means master. Always pick up one process-based entity. Like if you are going for a banking, so simple thing is what is the process? So you say, okay, deposit is one process, withdrawal is a second process. So start with deposit. So you take a entity, name it as a deposit, keep in middle, and then you see for this deposit, what are the direct entities? That means subject-based entities are required. So immediately your mind will come, okay, who will deposit? Customer. So it means customer will deposit. So keep the customer and make the relation between customer and deposit. So you'll find that, okay, between customer and deposit, no other entity will come. It is a direct relation. Now, when you go a little bit deep, means when you go in the domain, then you'll find that, okay, how customer will deposit. So deposit is a process, fine. Customer is an entity, master entity is fine. But is it like a customer will go and deposit, but where he will deposit? Then answer will come, okay, he will deposit in his account. So it means account is a one entity, and account is a noun, so it is also a master entity. So customer deposits money in account, so you'll find 2 master entities for deposit. So that is fine. Now the question comes, okay, where is the account? Because account is a virtual. When you start looking around, you'll find that there is no physical entity as account. So where actually I deposit? Then you will get answer, okay, account is maintained by the bank. So it means I'm going to deposit money in the account, but account is within the bank. Now here, if you see, you are depositing money in the account, not in the bank directly. So your money will be deposited in the account, and account is within the bank. So here you'll find one more entity is there associated with another entity, and both are now. So if you say account is your active entity and your bank becomes passive entity, that means it is like a reference master. So bank is acting as like a reference master, because bank has no direct relation with the deposit. Direct relation with the deposit is account, and account is within the bank. So it is a bank is acting as a reference master. So this is the way how you have to start. If you start by mistake with the most of the time people they do mistake, they take like whenever they start designing, the first thing they will draw customer. That is a mistake. The time you say customer, then they say customer has a relation with the account. Then we ask, okay, how the customer has a relation with the account? Then they start confusing. Okay, customer I will use for deposit. So you'll get one process deposit between customer and account. Okay, apart from that withdrawal, so you get another process withdrawal between customer and account. Then it is like, okay, means I'm giving a charges. So I'm paying charges for account. So that is another process, means paying charges. So you find that, okay, between 2 entities, now I'm getting so many entities, sub entities, because you started in the wrong way. So always start with one process. And the another mistake which is done by the when you go to the process, you have to see whether you are starting with the lowest level of the process or you starting at the higher level. It means like sometimes a process is a group of process. So like when suppose if you see in the banking database, you will find the deposit table, withdrawal table, you will not find. You will find transaction table. So it is a transaction is basically group of process. It means transaction is a process, but transaction involves so many processes. A bank might have maybe 10, 15 different processes are there, which is combined as a transaction. So if you start with the transaction process, again, you are going to struggle. So check that when you take any process, see whether this process is at the individual level, it means at the lowest level, which cannot be broken further, or can be divided further? If yes, that is the best way. By mistake, if you take the group of process, then again you will get confused. So suppose if I'm working, okay, deposit is one process, withdrawal is another process, paying charges is third process, interest deposit is fourth process. Like that, many sub processes I define. And then I thinking, okay, for this process, I need 4 master entity. For second also, I need the same 4 master entity. For third also, I need the same 4 master. You'll find that, okay, for these 10 processes, my entity set is same, or maybe 1 or 2 are changing from one to another. Then you'll get the idea, okay, then why should I keep these different process as a separate table? Why not combine them into one single table, means one single entity? That is the right way, because chances of doing mistake or missing sub processes will be completely eliminated. So don't start with transaction, start with the lowest level like deposit, and see how many entities are required for deposit, how many entities are required for withdrawal. You'll find, okay, deposit withdrawal have same set of entities. Club it, means keep the deposit and withdrawal together as a one entity. Now once you club them, then what should be the name? You cannot say just a deposit withdrawal, means you cannot combine both the name and make it as a common name for common entity or combined entity. So then you will start thinking, okay, what is the logical name I can give which basically represents both? So if you are not getting that name, then you discuss with your BA or business users. They will tell you what is the common name they are using in their business. So that name you can use it. So this is important, means don't just go. First thing is start with the process-based entity. Second important point is make sure that the process is at the lowest level. It cannot be broken further, or cannot be divided further. So then it will be easy for you to identify the perfect set of entities which are associated. Second thing is when you are working with the process, make sure that when you are linking a process with other entities, don't take other process entity. First, you take all the master entities or reference master entities which is required for this process. It means if I'm taking deposit, find out what are the noun-based entities. It means subject-based entities which are associated with this process of deposit. So deposit customer is required, deposit account is required, deposit bank is required, deposit branch is required, or deposit ATM machine is required. So all these are subject-based. Identify them. Then you'll find, okay, when I'm dealing with the branch, then they say, okay, branch, what is the location? So it means branch has a location, or ATM machine has a location. So you'll finding other subject-based entities which we can refer as a reference entity, because one entity is linked with the another entity. Or you can say like a parent master entity. Some people refer it as a parent master, child master. Some refer it as a reference master and master. So when you go to the different organization, they will be using different nomenclature. So different naming approach, like parent child. Sometimes they say header and footer. Sometimes they say like other name is 3-4 different terms are there. Parent child is one, header and footer is third, and then I'm not getting the third one. These three are very common approach to define the hierarchical relation, means one to many. So these are the some points which you have to, if you work, it will be easy for you to make a proper diagram, means data model. Plus, you will be able to explain why you are doing this and why you are not doing this, or why you are merging them because of the common entity set attached with this. So take one process entity, take one, identify subject entity. Once you identify like deposit and customer, so then you see what is the type of relation between two entity. Type of relation can be any of these three, either one-to-one, one-to-many, or many-to-many. When you are working with RDBMS, means our database system which we are using right now, none of the RDBMS system supports many-to-many relation. So at the physical level, when you go, many-to-many relation based entities, they cannot support. That means you have to break this many-to-many relation in the form of one-to-many and many-to-one. It means you have to introduce third entity between these two. And the relation will be from A to this third entity, one-to-many relation, and from B to this third entity, again one-to-one relation. Or you can read in flow, one-to-many, and from this third entity, it is many to one. So now sometimes question is why you introduce third entity in your database, why you introduce third table in your database. If customer is there, deposit is there, and suppose there is a many to many relation, why you are keeping a third table? So answer is very simple, because database system does not support many to many relation. That's all. That is a simple answer. No need to give a big explanation, because system does not support, our database system does not support. So we have to break into one to many and many to one with the help of third table. Now, when we are checking the relation between two entities, means customer and deposit, so always check the relation from both ends. Don't check only from one end. This is the biggest mistake I have seen many data modelers they do. They check only from one side and say it is one to one. That is wrong. So if it is like a customer and deposit, so check that one customer, means always put a questions like this: one customer, how many deposits? So answer will be many, because as a customer I can deposit many times. Even a single day I can deposit many times. Across the days, across the weeks, I can make so many deposits. So one customer, how many deposits? Answer is many. Now reverse this question: one deposit, how many customers? Like, is it possible that one deposit can be done by two or more customers together? Banking system will say no. One deposit is only by one customer. Sometimes people might confuse you, but suppose if it is a joint account, means one account is there with two customers and deposit is made, then so we should not get confused, because when we are talking about joint account, we are talking about basically who is going to make deposit? Only one customer. It is not like both parties or all the 3-4 parties will come together and make deposit. If any one of them is making deposit, it means he is representing the group of customer that is represented by account. So it is like one side it is one to many, but other side it is one to one. Then this is the one to many relation. If suppose both the side it is one to one, then you can say one to one relation is there. Generally in any database, it is a very rare that you will get two entities with one to one relation. Means maximum you will get 5%. Beyond 5%, it is not possible. So people unnecessarily they start making relation, say that no, this is the business rule, so it has to be one to one. So it happens. Earlier it used to be there, like we used to be very careful. I'm talking about 20 years back. People, many entities, they used to define one to one relation. But in today's time, when we know that things are changing so fast, companies are changing their business, adding their new business so quickly, it is very risky to have a one to one relation based entities, because tomorrow you don't know when the business rule will change and it becomes one to many. So the safest one is go for one to many. So whenever you find there is a one to one relation, make sure that okay, this one to one relation is always going to remain one to one. Means whatever may be the scenario, it will not change. It always remains one to one. Then only you take or consider one to one relationship, because one to one relation means you can merge both the entities into one entity. So you don't have to keep two. So in a very simple way, you don't have to create two tables. You can merge both the entities into one single table with a proper name. So if it is a pure one to one relation from both ends. So we'll discuss, like we'll see some example, but as I said, it is very rare. One to many is very common, and many to many also is very common. So generally, when we want to reduce the number of tables, then we transform many to many relation mostly into one to many relation as per the business rule. So one to many is very common. Like I give an example. If suppose I'm going for customer and deposit, so one customer many deposit, but one deposit only one customer. So it is one to many relation. Who is one? We refer them as a parent. And who is many? We refer them as a child. This is very important. The time you get one to many relation between two entities, it means you know who is the parent table and who is the child table. And once you know parent table and child table, then you should never be confused that which table primary key will be used as a foreign key and under which table. So it is very simple formula. There is no second thought. Primary key of the parent table will be used as a foreign key in the child table. So that means if I'm having a customer table and having a deposit table, I know that one customer, many deposit. That means customer is a parent table, deposit is a child table. So now it is very clear. So whatever is the primary key column of the customer table, so whether it is a customer ID or whatever, generally I prefer single column as a primary key. And that single column also, I don't take a real column or real attribute as a primary key. I always introduce a dummy column like customer ID. Customer ID is not a real value, it is a dummy value. Account ID or account number is a dummy value, it is not the real value. So always every entity should have one dummy column which we take as a primary key. This dummy column is mostly referred as a system generated primary key. Whenever we say that system generated primary key, that means we are talking about one dummy column in the table where value of the column will be generated by the either database system directly or by the application. There won't be input. User input is not there. Why don't we have user input? Because user input can be duplicate. And if you have put a check that, okay, duplicate is not allowed, then a lot of time we waste. Means person will keep on giving values, and your system will keep saying, it is already there, it is already there. So to avoid this, to save the time, it is always like that primary key will be generated and populated there. Rest of the attributes user will input. So it means customer ID, if it is my primary key, I will take customer ID column in the deposit table, and there it is referred as a foreign key. So it is very clear. What is the primary key? A column which is identifying the unique record within the table, that is a primary key column. And when this column goes to another table, there it is referred as a foreign key because it is not the attribute of that entity. It is derived from some other. So that is why they refer to as a foreign. So if it is one-to-one relation between two entities, then there are two ways. Either you keep both the tables, means both the entity as a two separate table, or you can merge both the entity into one single table. So it is your choice. As a data modeler, you take a call. And both way it will work. In one way, it is like two tables are there, so number of table is increasing. If you want to reduce, then club both the entities and keep it into one. So like you see this, I've given example, person and voter. One person, one voter. So this is like if I'm a person, I can be only one voter. I cannot be two voters. So that is very correct. So it is like I can just give only one vote. But if you go in a deep, there are situations where one person can be multiple voter. Like if you see in Sansad also, like who is the chairman, he has a I think two voting rights. So he can be two voter. He can give two votes. So if that kind of situation comes, then it becomes one to many. So within the organization also, it is like whoever are the employee of the company, it might be their voter in the company. If there is a company election, like suppose there is a union, means a staff union is there. So every staff is a voter also. So if you are designing data model for that part, that process also, then it is like one employee, how many voters? It is one voter only. So company says, no, in my case, it cannot be two votes. It is always one. So it is like a employee himself is a voter also. So should I keep employee as a separate table and voter as a separate table? Or should I keep the voter attributes within the employee table? Or should I keep the employee attributes within the voter table? So then some doubts will come. So it means there are three possibilities. So suppose if you are going for two different table, then there is no problem. Means one person table is there with maybe 15-20 attributes or more. Other voter table is there with whatever attributes, 2-3 attributes or maybe more. Then you have to make the relation. But the only problem is the relation is one-to-one, both the side. One person, one voter, one voter, one person. Then how you relate? Because if it is one-to-one relation, then how you know which is parent and which is child? If it is one-to-many, very clear. One is parent, many is child. But in case of one-to-one relation, how you define? So here comes when you are not able to decide the parent-child based on the type of relation, because it is one-to-one, then you have to take another approach. And that approach is between these two entities, person and voter. Who comes first and who comes next? That means existence-wise, who comes first? Like in case of parent-child, parent is always first. Means existence of parent is first and then only child will come. So use the same logic between person and voter, whose existence is first. So we say that first person will come, and then comes voter. Because if there is no person, there is no voter. So person first, voter second. So first is a parent, second is a child, or next is a child. So that is one second way. Third way is like you can think about compulsory or optional. Means who is a compulsory? So we say parent. Who is optional? Child. So it is like a person is a compulsory. Voter maybe, may not be. So that is the third way of identifying parent-child. So compulsory is a parent, optional is a child. So once you are able to know, okay, who is the parent and child, then it's very easy to make the relation. Means you will never do mistake that, okay, let me take voter ID within person. That is wrong. It will work because it is one-to-one relation, so you will not face a problem. But as per the rule, it is not correct because voter cannot come before person. So if it is one-to-one relation and you are going for two table, then see who comes first and who comes next. Person means parent comes first, child comes next. So primary key of the parent should go to child. One to many, very simple. One is parent, many is child. Now, when it is many to many relation, in most of the databases, most of the entities, actually they are many to many, but we define them as one to many or one to one. But if you take my example, like I told you earlier, when it comes to data vault modeling, basically they consider every relation as many to many. They don't consider one to one or one to many at all. Just they say if two entities are there, assume they are many to many. So they made it very simple. So in case of many to many relation, like for example, if you talk about person and language, like here is there, one person can speak many languages. So it is person to language is one to many, and one language can be spoken by many persons. So again, it is many. So it is like one person, how many language? Answer is many. One language, how many person? Answer is many. So both the side you are getting many answer. So that means it is many to many relation. Now it may be possible that this company said, no, I don't consider. In my company, when a person is joining, I will ask only one language, English, that's all. So it is fine. It looks okay. As per the business rule, it should be one to one or maybe one to many. Instead of one to one, it will be like one language, many person. But you have to be careful because it might be possible in future they will consider, okay, who are the persons knows the 2 or 3 languages, because based on the location of the project, they might require that person should know English as well as French also, Chinese also, or if he's going to product in Japan project, he should know Japanese. If anyone knows Japanese, it's good. So earlier, when I used to design the database, they were very specific. No, we are dealing only in India. Why to bother about other language? So just if he knows the one language, that is enough. But over the period of time, you'll find that now language has become one of the important attribute. So whenever companies recruit the guy, they always ask what are the languages you know, and that is why it has become part of our resume also. So very clearly we mention what are the languages you know. So people they mention 3-4 languages, so they maintain. So it is like a one person, many languages, and one language always many persons are speaking. So this is a one instead of one to many, it is a many to many relation. So as I said that RDBMS does not support many to many relation, it means within the same table or within the 2 table, you cannot maintain this. So you have to introduce a third table. So it is like a person will be one table, language is another table, and then in between there will be one more table which will be the relation or association. So whether you keep the name of this third table as a person language, if you don't get any proper name, then combine it, person language. Or if you get any proper name, like person speaks language, so you can keep like speak, table name speak, or communication mode, or whatever you decide. So it is like this third table is always a child for both the table. So here it is like both are parents. So you can say like mother and father and then child. So this child is going to inherit something from father and something from mother. So it is like a person is a parent table, language is a parent table, person language is a child table. So primary key of person will come to this third table, and primary key of language also will come to the third table. And that is the reason I don't prefer composite primary key, because you see here, if it is suppose in person I'm taking composite primary key, it means two columns combination as a primary key. In language also I'm taking two column combination as a primary key. Now when I'm going to this child table, that means in this child table, two columns will come from the person and two columns will come from the language. So this child table will get four column as a foreign key, which is unnecessary because it is increasing the number of tables, sorry, number of columns. And if you see, when you go to the query level, whenever you are going to write a query which includes person with person language, you have to write two join condition because you are using a primary composite. So for one join, you are using two condition. For two join, you are going to use four condition. So that means your query performance also will take join because take time. Instead of processing two condition, it has to process four condition. So never take a composite primary key. My approach is very clear. I don't take composite primary key. Sometimes people say that, oh, but this is my last level table, end level table. It means at lowest level table. So I can keep composite primary key. So my question is very simple. Today is a means last level entity. But suppose tomorrow, if the business extends and this table becomes parent for another table as a child, then you made it primary key, your project is over, you are gone. But after 6 months, when this table means this system extended, and now some more tables are added, and some of the tables are child for this parent, this table which becomes now parent. And here you took 3 column as a composite primary key. Now all the child table will get 3 column as a composite primary foreign key. So never assume that what you are doing, it is the end. It is bound to extend in future. When it is not able to extend, then they go for redevelopment, means redesign, redevelop. Why it happens? Because somebody in the past, he has done very highly denormalization, means he has assumed that, okay, it will stop here, it will not go beyond that. We should never assume, because the way business is growing, you cannot say that, okay, this is the end, it will extend. So it is always better when something is available that, okay, by taking one system generated primary key, I can avoid composite primary key. Do it. That is always very safe. So this is the way how we have to deal with the relation among the entities. One-to-one is very rare. Whenever one-to-one situation comes, you take a call. Do you want to merge it as a single table? Generally, my approach is, if suppose person is one table, voter is another table, what is the attribute I require for voter? If it is just one attribute or two, I will merge in the person. But if it is more attributes, then I will prefer two separate table. That is my approach. Means it is like just voter ID is required. Then I will keep voter ID within the person table and make that column as an optional, because it may be, may not be. But suppose if they say, no, I need voter ID, when he became voter, means voter date, voter expiry date. If such kind of attributes are there, then keep them as a two separate table. Because if today there are 3 columns, maybe in future it might become some more columns might be required. Like they say voter type, voter rights. So if that type of things are coming, then you have to give separate table. So one-to-one, either you make it one table or you keep it two tables. One-to-many, you always have to go for two tables. Many-to-many, you always have to go for three tables. Because if many-to-many relation is there, even though if it is a one column, you cannot keep in one single table or two single table. That is not possible. You have to introduce third table. Yeah, any question or any doubts till this point?
Rahim bhai, when you are saying many to many, so and we have to mandatory create a one more table. Since database doesn't support many to many.
Yes.
So like give an example and how we are creating a relationship, just with the help of diagram if it is possible, or if it is coming in further class, I'm fine.
Yeah, it will come. We will take examples, but we can discuss like examples. Suppose we are talking about, I gave example of customer and deposit. One customer can make multiple deposit, but one deposit only one customer. So this is pure one to many relation. Is two table, fine.
Yeah.
Now, if suppose you go for supermarket, means retail business, you have a customer and payment. Payment is a process, and who makes the payment? Answer is a customer. Payment is made for the bill. So first let us consider customer and payment. One customer, how many payments?
He can make many payments.
Many payments. Now reverse it and check.
Many payment.
No, don't say many payment. Always one.
Sorry, one payment can
How many customer?
be only one.
So
Or
it is a one-to-many relation. So always put question like this: one customer, how many payments? Then see answer many. Now take the question other way: one payment, how many customers? So this is the way how you make the sentence. Don't say many payment. If you say many payment, then you are gone. You are lost. You'll be doing a mistake. So always, whichever side you pick up, put this question: one customer, how many payments? Answer is many. One payment, how many customer? Answer is one. So it is a one to many because one side is answer many and other side is answer one. So it is one to many. Now take the example: payment is against bill, correct? So it is like bill is generated and payment comes. Now bill has a relation with the payment, the way customer has a relation with the payment. Now one bill, how many payments?
one bill, one
multiple
payment.
one.
Means
Can
one
be
bill,
multiple also.
it
Maybe
can be
half,
multiple. Yeah, means part
maybe
payment.
half credit card, half cash.
Yes. Not only that, it may be like that supermarket is giving you because you are a regular customer, permanent customer, so they might be giving you part payment, like you can 3 installment, you can make the payment, 3 part
Yeah, EMI options.
EMI options. So it is like one bill. How many payment? Answer is many. Now reverse is one payment. How many bill?
One payment, one bill.
No, it is like I give very simple example. In nearby your house, in your street, there will be some grocery shop, and you are regular purchaser of the grocery items. So you will go, your wife will go, your kids will go. So what you said your shop owner is, I will make you monthly payment, correct? Every month I will make you the payment. So whenever my family member comes, give them item and note it down. So what he will does, whenever anyone goes to buy, he will make a slip, he note it down and give that slip to you and make one copy with him. So at the end of the month you'll go, you will have a 50 slip, that is a 50 bills. How many payment you will make? 50 payment or one payment?
One payment.
So it is like one payment, multiple bills. So it's very common at the very lowest level. We use this approach. In business, always they use. So here you'll find that payment and bill has many to many relation. One payment can be for many bills combined together. One bill can always have a many payment like part payment. So here you get many to many relation. Then what you do? So it means between bill and payment, you have a third entity. You will require third entity. But between customer and payment, it is a one-to-many relation. So you don't require third table between customer and payment. So customer is one name, payment is third name, second name, bill is third. What will be the name of this fourth entity, which is between the bill and payment?
We can combine them like bill payment or something, payment bill.
This combination name should be only after some thoughts. If you don't get any proper name, then you can go for combine. You know how this generally most of the data modeler, they make this table name. They say that payment header, payment detail. Have you seen this kind of table?
Yes, I think I have seen somewhere.
Yeah, or sometimes they keep payment master, payment detail.
Yep.
So this is the way how when they don't get a proper name, a proper process name, then they keep this like payment header means they say that okay, whatever payment details are only one time, we'll keep in header. Whatever payment details are repeating, we'll keep in the detail. So you can say like payment master, payment detail, or payment details. So that kind of naming you can use. So if you don't get any proper name, it is not always possible that this third table you will get a good proper name. So when you don't get a good proper name, you can combine or you can keep some kind of this kind of things. Means because both the tables are for payment. So I will keep one payment table as a header, another as a detail, or one payment table as a master, other as a detail. So like that, this kind of naming is very common. So you have got the customer. Customer has a relation with payment header or payment master. Payment master has a relation with payment detail, and payment detail has a relation with the bill. So you got the four table. So out of these four table, two are master entity, customer and bill. One is a transaction entity, that is a payment, and third is a association, payment detail. So this, if you go in this, like we started with two entity, we got the third entity, third, and then when we make the relation between the second and third, we got the fourth table. So this is the way how your database objects will increase. So if you try to take 50 entities in front of you in maybe like a year, means any data modeling tool or PPT or any other, and then you try to relation, there will be mistakes. So never do that. Keep like 200 entries names are there in one sheet. Like you create one PPT and keep all the 50 entities in that sheet. But out of that, pick up two, keep in other sheet, make the relation. Might be you get third table. Then you take the third one, put in this, and then you see where it will be associated. So it was like, okay, let me.
Hello.
Hello.
Yeah. I'm not able to hear.
No, no,
Oh,
right now. Can you hear now?
yes, yes.
Yeah, I was just working on this.
Okay, okay. I thought something issue.
Instead of this, let me take. So between the customer and payment, so if we go for relation, so we can take one to many. Let me add one column. So you can see this when I took customer and payment relation, primary key of the customer has become foreign key in the payment table. So it is a customer. So what it does is it basically it has added its own customer ID means new. So I have to change. This is the problem with the Oracle data model. So I can make changes and remove this additional part. So this is one-to-many relation. So now this is another problem. Sometimes notation, like if you go to this notation, arrow side is a parent and the other side is a child. So in Oracle Data Modeler, they use this approach. Whichever end is the arrow, that is the parent table, and the other end is the child table. So always, whenever we create the relation, what we do is we take this relation, click on the parent table first, and then click on the child. So now if I go to this bill payment details, so here itself I can. And then between payment and payment details. So here we can see this in the payment detail, you have a two foreign key. One is a bill ID, other is a payment ID. So bill is a parent table, payment is a parent table. So both the foreign keys are there. So it is a see, you can see the advantage of using a data modeling tool is designing this is very easy. The same thing which when I was trying in the PPT, it takes more time. Here it is very simple. Just to click relation is done, arrows are there. All these things you don't have to design manually. It will be by default. Plus, when you convert this into SQL code, it will generate the SQL code internally. You don't have to type it anything manually. So these are the means this is the way how you draw your diagram now. So these four tables are there. Think about any other entity which you think will be required here. Means customer is making the payment against the bill. So now here how the mistake is done. Some people what they do is they take the customer table and they take the bill table. Now let me show how the other people they do. So they take the customer table and then they take the bill table. And they say customer has a relation with the bill, which is very clear. Means every customer has to make the payment of the bill. Now, if you go in this approach, means you are not taking the process and you have taken both the entities which are basically subject oriented. Now check this relation. One customer, how many bill? Answer is many, because one customer can get many bills. Now, one bill, how many customer?
One customer.
One customer. So if you go with this approach, what you will get? One customer, many bill, and one bill, only one customer. So you will make the relation, okay, customer to bill. See, it says primary key is not there. So until we add a key, so this is the relation. So one customer, many bill, and one bill, only one customer. Now this mistake is done. So you made the relation customer and bill. So you'll find, okay, it is, since it is a pure one-to-many relation, so that is fine. Customer has a relation with bill. Now, problem here comes when you start implementing this, you'll find that, okay, one customer can make payment for multiple bill. So you are getting this payment ID, payment date, and then there is a bill ID, bill date, bill number. So where to keep this payment detail? Then you realize as a data modeler that, oh, I cannot keep the payment detail in the bill because one bill has multiple payment and one payment has multiple bill. Then people start, what they do is they will take, okay, let me take the payment table also. So they will go for payment. And they say that one bill, many payment, one payment, many bills. So, okay, between these two, I should have one more table. So they will go for this. So here they will add payment ID. Means I'm showing the how the mistake is done. See, this is the advantage of a data modeling tool. If you try to relate two tables without primary key, it will not. So this is one relation, and this is another relation. Now, do you find any difference between this approach and this approach? Both have four tables because customer and bill relation was one to many, and then bill payment and payment. So which one is better? In one case, customer has no direct relation with the bill. In another case, customer has a direct relation with the bill. So which one is better?
First approach is better because it is linked to process, and
Yes.
uh, in this case, second case, bill and customer are tightly coupled.
Yeah, if you discuss with the business user, what business user will say means where you will be getting confused. A business user says that, okay, see, in my organization, bill is generated and the bill is sent to the customer and then payment comes. That is one. Second approach is when you are visiting any supermarket physically, what you do, you don't get the bill immediate. What you do, you make the payment, bill generated after your payment, or bill and payment both are together. So if this situation comes where you have both the scenario, means like if it is online, in case of online, what they do is you give the order, you make the payment, you get the bill. That is one use case. Second use case is you give the order, bill is generated, it comes to you, and then you make the payment. That is a cash on delivery. So if there are two scenario in the same organization, means when payment is made first, then you get the bill. Second, bill is generated and then you make the payment. So how you handle this, both the scenario? Because association wise, in one association, customer has a relation with the payment and then bill comes. In second case, customer has association with the bill and then payment is made.
So is more both the approaches is depend on the process wise. If one business say okay, I want to generate bill only after payment, and then first
But that is I'm saying now, like in this, like you see this Amazon. When you go for Amazon, what happens? You give order, you make the payment, then product comes with the bill, correct? Second case is cash on delivery. You give the order, product comes with the bill, and then you make the payment. So both scenarios are there in the same organization. Then how you design?
no idea.
Yeah, anyone else? Because both the scenarios are there. In one business, they will say that because nowadays business are flexible, so they have to provide both the feature. Means it is like you make the payment, I will send you the bill. Other says okay, I will send you the bill. Mostly in the business to business case, it is like a payment is rarely first. First will be the bill. So it is like bill or invoice, whatever word you use. Bill or invoice is generated. It is sent to the customer, which is again the organization, and they have some time, 15 days, 30 days, 45 days time. Then they make the payment. So first they collect the bills, and then against the bill they make the payment.
Can we design both of them and keep a two separate process?
No, that is not possible. In single database, you cannot have a two customer, two bill, two payment. No, it has to be only one.
Got it.
So, in first case, suppose we made relationship between customer ID and bill also, so it will complete the cycle.
Sorry,
Either way
repeat.
it can. Suppose in the first option, we have customer. There is no direct relationship customer and bill. So can we make a relationship between customer, directly connect customer and bill? So
Yes.
either way, if you go, in that case,
So you
it
want
will
to go this way, correct?
right.
See, this becomes circular relation. That means if you are here, there is no exit. You cannot come out. So this we refer as a circular relation.
Okay.
And we should avoid circular relation as much as possible. Sometimes circular relation becomes compulsory. That is a different scenario we'll discuss later. But here, when you make the circular relation, then it becomes very dangerous.
Can we combine bill and payment table?
It is already combined. Na? See, bill has a relation with payment. Only thing is because of many to many, this table has come, correct? So bill and payment relation is already there with the help of these associate entities or associate table. See, whenever you find a table which has a two parent, it means it is a associate table, means it is because of many to many relation. That is very simple way.
Got it. कस्टमर को बिल से जोड़ रखा है यहाँ पे कस्टमर को पेमेंट से
So this scenario becomes confusing. Means now here your business domain knowledge becomes important. If your domain knowledge is not there, you will keep on moving in this. You will be confused. Now, if you go back to supermarket, when you go to supermarket, you take the items in a basket and go to the billing counter. Is it possible that you make the payment without bill?
No.
So if you see this in any business, a payment is never made without bill. It may be bill is not printed, that's all, but bill is generated. Once bill is generated, then only you make the payment, correct? Like when you are standing on the POC, means point of sales counter, POC counter, what happens? Your item will be scanned on the screen, it is added, and amount will come, correct? And then bill details, all those will be there on the screen. Bill number, everything is there. Amount will come. That amount is told to you, and what you make? You make the payment. You are making the payment against the bill only, correct? Only thing is bill is not printed. Printing bill is different thing, but without bill, you don't make the payment. If suppose the bill is not generated, means you go to the you take the items in the basket and you go to the counter, and counter person says that okay, it is a 500 rupees. Will you give? You will not make the payment because they'll say, where is the total? Where is the detail? Means you have not added the items. What is the quantity? What is the rate? What is the total amount for each quantity? What is the sum of those amount? Until that process is done, you will never make the payment. That happens when you go to the like roadside, means person is there, there is no billing system. It is like you take the items, ask, he will add something on his finger and say 500, you give me. Because there is no system. It is like barter, means you can barter system where you are giving the money, you are taking the product, that's all. But when you go to the system wise, you will not find any organization will say that I will make the payment or I will take the payment or receive the payment without bill. That is not possible. Even though if you go online also, any website, what you find is when you make the payments, you take the item, then they go to the next screen where they show the item rate, whatever is the quantity, whatever discount they apply, everything. Then finally a screen comes where they say this is the payable amount. So it means bill is already generated. Only thing is once you make the payment, they will print the bill and send to your email or whatever, maybe your mobile. But if you don't make the payment, then they say oh, bill is cancelled. Means everything is cancelled. Nothing is generated. So if you see, a customer does not make the payment directly. A customer makes the payment only through the bill. Correct? So when I said this customer and payment, customer makes the payment without bill. That as per the business rule, it is not correct. They will say, no, this is not correct. We never receive any payment from the customer without bill. So if the business rule is very clear that payment is always against the bill, not against the customer, then in that case, what we have done in the first approach, that is wrong. Because nobody will make the payment without the bill. So when we took this payment entity and we took the customer entity, there itself mistake was done. Because when you check with the business analyst or business user and say that, okay, payment is from customer, he will say, no, payment is from customer, but it is not direct. payment is from the customer against the bill, he will say. So that means he's telling that, see, payment is against the bill and bill is given to customer. So once you get this business rule or this business understanding from the business user or the BA, then your design will change. Now you find very clear that payment is directly related to bill, not to the customer. So when you got this idea, okay, payment and bill has a direct relation, bill and customer has a direct relation, then your relation will be correct. That is why I said earlier, identify two entities which have a direct relation. If you mistake there, then your design is gone. Means it will be a big problem, like what we have done here. So this is wrong because payment and customer has no direct relation. What is the link between them? Between customer and payment, there is a bill. So this one is the proper one. Only thing is, in both the cases, I shown you a different way. Like what I should have done is, here I took the payment and customer starting point, which was wrong because there was no direct relation. Here I took the customer and bill relation. This was correct. Customer has a direct association with the bill. Between these two, there was no process. So that is fine. And then I find, okay, bill has a relation with the payment, but it is a many-to-many relation. So I got this third one. So when I say that between two entity, you have to check. In some business, they say that between two master entities, there might not be any process directly. Like in case of customer and bill, they say customer and bill has direct relation without any process because bill generation is a process. But they say that no, I just need a bill detail, but bill generate, how the bill is generated, where it is kept, that detail I don't require. So there is no process as the bill generation or bill generate. So that is why that bill generation process we are not capturing. So it is like customer entity, bill entity, both are master, but both have a direct relation without any process. That is fine. Because what we are looking for is whenever you take two entity, just check whether these two entities are directly related or there is a possibility that between these two, there might be another entity. If there is a possibility, identify, get it that, keep between them and then make the relation. So this is the very important part. Just blindly like what we did earlier, if you do this, there is a mistake. Because when you design this and go back to a business analyst for verification or confirmation, then you'll find, oh, it is a mistake. Means first customer will get the bill and against the bill only will be the payment. Then you have to change it. And suppose if there is no business analyst and generally business users, if you don't interact in a proper way, because those people generally are busy with their physical activity, they don't give much time. Whatever you ask, they will say yes, yes. So generally interacting with business user directly is very risky until you are very careful. Means you are doing a lot of cross questioning. If you do cross questioning, then only you will get the real picture. Otherwise, they will say yes, yes. Whatever you say, they will say yes. But if you have a business analyst, then he is your team member. Basically, he is from development team, means solution provider. So he will sit with you and whatever you ask, he will explain you. Then you get the clear idea. That is the reason this data modeling for a data modeler, for newcomers data modeler, why it is tough because of this scenario. You can see that both cases were looking good. Means when we did the first, it was perfect. When we get the second, that also is perfect. When we discuss with the business point of view, then we'll find we got confused how to do because customer has a relation with payment, bill has a relation with payment. Then we got confused. So the only thing which can save you is you have to find out direct relation, direct association. If you are able to identify which two entity, whether two master entity or two transaction entity or one master and one transaction, if they have a direct relation without any third entity between them, then you go ahead. Getting that one is tough because that requires a domain knowledge. So this is the area where mistakes are done. Mistakes are not done like, you know, what is the rule? Okay, 1-to-1, I will keep one table, one-to-many, I will keep two table, many-to-many, I will keep three table, parent table, primary will go to child table. These rules are very predefined. There is no change in that rule. Everybody knows. The only problem is how you apply these rules in a different scenario. Means one business says, I will not allow one customer to make more than one bill payment at a time. Business rule is changed. Other says, I will allow my customer to make multiple bill payment in one single payment. Business rule is changed. So in one case, you have only 2 table. In other case, you have to go for 3 table. So until you know the business rule, and sometimes, as I said earlier, business rules are given by the business. But if you design as per those business rule, by the time your project is going to the live, means implementation stage, their business rule is changed. Now they say it is a one-to-many instead of one-to-one. At that time, if you say no, but earlier you said one-to-one, then what means a statement comes from the client. You people are expert. You should have suggested that. That is very common statement which comes from the client whenever they are in the problem. Means whenever just because of a small change, you say that now need to go back to the database, make a 2 table changes relation. Because of that, these 3 application will be affected, 5 reports will be affected. Then again, testing of the database, testing of application, testing of reports. All these process, when you note down, you say that it will take 3 weeks time. And for that, you show the charges. They say that I just change one rule and you are giving me a list of 3 weeks changes and some $1,000, means $10,000 or $20,000. So that becomes a problem for client. And they say that, then why you people, you say that, okay, you are a solution provider, you are expert in the banking or all this. So this is very common statement which comes. That is why data modeler is a very important. The problem with the data modeler is whatever you design, there is nobody to verify your work, because data modeler is one person in the team. If suppose data architect is there, he may be able to verify, because if he has become data architect after data modeler, then he will be able to verify. But nowadays there are many data architects who become architect but without any prior experience in data modeling. So those data architects, you'll find that whatever you do, they say yes, it is fine. You have checked it, you verified, that is fine. So they say that's fine. So problem with the data modeler is nobody is there to verify whether you have done anything wrong. So it is you have to review again and again. You keep on checking a business rule, check again your diagram. So it is like multiple review. Your own review has to be done with a different mindset as per the business rule. Then only, and if you miss all these 2-3 review you did, and you'll find, okay, it's fine, and then gone. So if you go with this approach, it will become a problem. So these kind of things means practically it comes when after means you go through some 2-3 projects, you means good projects where you are dealing with a good amount of entities, a little bit complex, moderate complex, then only you will get these kind of scenarios. Means after 1 project or 2 project, when you go to 3rd project, then you realize that, oh, you did this mistake in the earlier project. See, if you go with this also, operation wise it will work. There is no problem. It will work, because ultimately customer has a relation with the bill. So what applications will do? They will populate the customer detail. They will create the bill and populate the bill detail. The only problem is customer and bill has no direct relation. So they will say that until payment comes, I will not be able to tell you this bill is generated for which customer. So that will be the issue. So when this scenario comes at the very end of the project, what data modeler will do? He will just go to the bill, keep the customer ID also, like he will make the circular relation. So job will be done. Means once you add the customer ID in the bill, it is done. And then everybody will be fine. Only just by adding 1 column in the bill, job is done. But it is a patchwork. It is not the proper. Proper is this one. And that was the, means when you make the relation, this will become the patchwork. Means if you show to anybody, they will say, yeah, this is perfect. Customer has a relation with bill, customer has a relation with payment. That is perfect, no issue. But actually, there is a issue. Customer has a relation with bill, bill has a relation with payment, not the customer direct. So if you go as per the business rule, then this relation is not correct. So whenever you get this circular type of relation, immediate your mind should click. Oh, it seems some patchwork has been done. That will come. There are some specific cases where this relation is perfectly fine. But in most of the time, whenever this type of relation comes circular, it means some patchwork is done. Means some mistake was done, either intentionally or without knowledge.
Okay. What will be the problem if this circular has exist?
No problem. See, the problem is, first of all, if you see, you are showing this as per the business rule, you are saying that customer has a relation with the payment, correct? If you see only this relation, suppose if I hide this one, what you are saying that customer is able to make the payment without bill. But when you talk to the business people, no, it is not possible, they will say. How it is possible that customer will make the payment without bill? So if you go as per the business rule, this is completely wrong. Means no customer is going to make the payment without the bill. So when you open this, then you find, okay, customer has a relation with the bill and customer has a relation with the payment. So as per the business, this is not correct. You are able to handle the situation because you did some mistake, you are able to handle, but it is like a patchwork. It is not a problem. So when you say that, what is the problem? Problem is like, if I go in minute way, first of all, one additional relation I'm making, that is a mistake. Suppose tomorrow, if somebody wants to write a query, so what he will say, should I use a customer payment detail link, or should I use customer bill and payment detail? So that person who is going to write the query to get the customer and the payment detail, he will have a doubt. Should I go with this approach, means these three table, or should I go for these three table? So there will be confusion. So just because of one small mistake, you are creating a confusion for your development team, application development team, your reporting team, both. Means always they will come back to you. Should I use this link, or should I use this channel to generate the reports or generate the query? Other thing is, means additional link is there. So at that, from database point of view, you created one more object, that is one more relation, that is additional. You added one more additional foreign key, means customer ID is here also, customer ID is here also. So one more column is additional added. So from database objects point of view, two additional objects are added without any use. It is like extra burden on the database without any use, just to avoid a mistake. So if this kind of mistake is done, suppose 10 different places in the same project, it means you are going for like 10 different relational object addition, 10 different foreign key addition you are added. And now if you are thinking like, okay, I'm doing this for ICICI Bank. So you think that one foreign key, it looks okay, only one foreign key, but one foreign key, 20 crore customers. So it means 20 crore into, suppose it is 16 bytes, those much of space, loading them from physical storage to virtual storage, additional process time. So it will impact the performance also. So as one single mistake might become very big when your client is having a very huge transaction. So this is important. Whenever you are dealing with entities, check that, always try to find out direct relation. Whenever you have a doubt, go back to business analyst or business user and say that, see, I'm thinking customer and payment has a relation, direct relation. Is it, or is there any other entity between customer and payment? They will tell you because they are dealing with this day in, day out. So they will tell you, no, customer and payment direct. It is through the bill only. So once you get the bill, then your things are very clear. So data modeling is not something where you just sit in the backend and until you are expert in the domain. If you are expert in the domain, fine, you will get these kind of things. Means like whenever I do mistake, whenever I find this circular relation, I know 99% time I know that I have done a mistake. Then I go back and check with them. Where is the fault? Means customer bill payment, which two have a direct relation, which, and third one has a relation with the which two, or out of these two, anyone. So it is like I have defined my own way to identify. Whenever I find this circular relation, I know mistake is done. So if suppose logically, I means business wise, if I'm missed it, when I go at the technical level, diagram level, there I find. So after designing any diagram, I just check where is the circular relation. If I find a circular relation, I know that mostly it is a mistake. Some rare cases are there where circular relation is very common. That we'll discuss later, but mostly it is a mistake. Yeah, any other query? So this is important thing. It will take its time. It is not like means you will start thinking in this direction from the very first project. So it will take 1 or 2 project experience. Gradually it will come, and you will come to know. You will define your own way to identify the mistakes. Sometimes it is possible you can come with your own way. But the basic process, if we follow, we can avoid most of the mistakes. That is the advantage of knowing these rules. Means when you follow the rules, mistakes like, I give a simple example. When you follow the traffic rules, then chances of accidents are very rare. If everybody starts following the traffic rule, like you see in US, UK, Europe, or in the Middle East also, most of the people, they follow the rules because of the punishment which they give, penalty they give is very high. So they follow. But when it comes to Asian countries, India, Pakistan, Bangladesh, accidents are very high because you are following the rules, but other fellows are not following the rules. So it doesn't matter whether you are correct or if others are not correct, then accidents will happen. So it is like you are a very good data modeler. Your domain knowledge is means average within the business analyst on you means whom you are depending about the information or clarification. He is not good. You will do mistake because he is doing mistake. He is giving you incorrect information, and based on that you are designing your model. So it will be a problem. So, but at least from data modeling point of view, whatever basic rules are there, if you know those basic rules, like I said, if suppose my business analyst gave me this kind of information and I made the relation. Once I get the circular relation and I know that this is a mistake, so I will sit with him and I will talk to him. No, it looks good. Not, it doesn't look good. Somewhere something is wrong. Then he will try to clarify, or he will get clarification from the business, and then he will come back and tell you. So there are different methods where you can trigger your mind that something is wrong. Let me get more clarification. Okay. Any other query or doubts?
No, from my side.
I am also good, Rahim bhai.
Yeah.
Yeah, I'm also good, Rahim bhai.
Okay. So this is means what you have to do is try to take all of you are working and you have having database. So many tables are there. So you can take 3-4 tables. I mean, see, whatever tables you have in your database, most of the tables are denormalized. So the best practice is you take one table which has like 30-40 columns. Any table you pick up which has 30-40 columns. Study those columns and see that whether all those columns belongs to same entity or some of the columns belongs to other entity. You will find if there are 40 columns, chances are that 2-3 entities attributes are combined there. So just to follow this basic rule, like read the each and every column name and see that with those attributes, what is the first word? Suppose if it is a customer name, then they say customer address, then they say customer date of birth, then they say phone number. So the time you get phone number, now you should know customer is one entity because it is noun. Phone is another entity because it is also noun. So why phone number is in the customer entity? So now you got two entities. So you can draw two boxes, one customer and one phone. And customer and phone has a direct relation that we know because it is a very common. So you find two entity, then you check one customer, how many phone number? Answer is one, or it can be many. So answer is many. One phone number, how many customer? Yeah, one phone can be used by many customer. But if your mind is filled with mobile, you'll say no, but mobile is only with one. Then you will do mistake. There they are not writing mobile number, they are writing phone number. If they write mobile number, then it is fine. You can say one mobile, only one customer. Like you see this from Aadhaar point of view. Is it possible that 2-3 person can use the same mobile number in the Aadhaar?
Yes, the many cases they are using.
It can be because it may be like in family they are using. So even
Right,
for
right.
Aadhaar database also, you will find that one phone number can have many means persons. So it is like many to many relation. No, it is all will not be many to many. One person they will have only one phone number. So one side it is one, but other side it is many. So there you will find that phone number is acting as a parent and the person is acting as a child. But generally we know that person is a parent and phone is a child because existence wise person comes first and then comes a child entity which is phone. But from Aadhaar database point of view, they say phone number. Now once you get this relation phone and customer, check that if suppose a person is in a village, maybe in a very rare village where there is no phone, do you think that that person will have a phone number or mobile number? No. Then how he or she will get Aadhaar? So is it possible that we can get Aadhaar without phone number or mobile number?
Yes, initially it was given, and then phone number was linked.
No, but still there are crores of people without phone number, mobile. They don't have,
Or,
but they have Aadhaar.
yes, I think someone else is given.
No, you can't. You can't say that. You cannot force it. If I take example of Adivasi area, correct? In the entire village, they don't have phone. Then, but they will get Aadhaar because that is the identity.
Yeah, it means phone number is not mandatory.
Yeah, it is not mandatory.
It's optional.
That is why if you see, what they say is for Aadhaar they don't say phone number. They say that when you are linking Aadhaar with PAN, then phone number. Aadhaar link with the account, phone number. So anybody who is opening a bank account for them, okay, they say phone number is required. But I'm not sure how they manage in the villages or Adivasi areas if they have a bank branch and if somebody wants to open account and she doesn't have phone number, how they manage. So these kind of questions, when we put ourselves in our mind, we start expanding our thought process. So it is not like until we have a project, then only we think. Like this kind of example you take, means if Aadhaar is there, or PAN is there, bank is there. So for Aadhaar, fine, I can assume that bank only for those customers who have phone number, bank account. But what about Aadhaar? PAN is also for those people who are paying the tax and they will have a phone. So there I can make it compulsory. Means government can make it compulsory. But Aadhaar, they cannot make it compulsory for a phone. Then how they manage? So start thinking in this way. So this nowadays, if you see, the biggest project is basically in every country is a citizen-based project. So if you start thinking in that direction, just create your own doubts, your own questions, how they might be managing. If there is no phone number, will they get Aadhaar or not? And if you have a doubt, you can Google, is it possible to get Aadhaar without phone number? You will get answer. So it is basically thought process. Modeling rules are very simple. Don't go at the rule, means the rules we are knowing that, okay, how many rules we know till now? Just 4 or 5, that's all. And we'll go for normalization, 5 more. So maximum 10 to 12 rules are there, nothing else.
Rahim bhai, sorry to butt in.
Yeah.
I'm just dropping out.
Okay. Yeah, I'm finishing up. Yeah, we can.
Okay, chalo. Thanks
Okay,
everyone.
okay, thank you everyone.